Hello, everyone. My name is Terence. Thanks for having me here. And today I want to talk about the most severe attacking vector in OT now, the ransomware. In addition to how badly the ransomware hit our business, where we, the OT community, are not ready, we will also go through some best practices we could learn from the real deals. I'm from TXOne Networks. This name could be new and strange to you because we were founded in 2019 and it's merely 2 years old. TXOne Networks is Trend Micro's subsidiary, and while Trend Micro focuses on IT and cloud security, TXOne focuses on OT and ICS by providing the leading industrial cybersecurity solutions. And in today's session, we will also cover why IT cybersecurity products not necessarily fit OT environment given so many limitations, and so why we will need the native OT cybersecurity solutions. Although we are young, but OT cybersecurity is now a very hot topic. So only in 2 years, we have acquired many customers around the globe. Recently, TXOne also won an award from Enterprise Security Magazine, and we are named as top enterprise security vendor in APAC. Also, thanks to Cyber Defense Magazine, during RSA conference this year, we won 2 awards, and they are Most Innovative in Critical Infrastructure Protection and Editor's Choice in ICS SCADA Security. First, let's take a look of what's going on in terms of current ICS threats. If we look into the chronic list of breach events, before 2017, it was mainly nation-sponsored hackers using very OT-specific technology to break into critical infrastructures. But in 2017 and 2018, there were some worm propagation breaches, and many large enterprises got hit badly. And from the end of 2018, we have seen more and more targeted ransomware attacks on manufacturers and critical infrastructures. We believe the IT-OT convergence and the evolution of ransomware technology happened at the same time, and therefore they have worsened the impact. This ICS specialized attack, worm, and targeted ransomware are the top 3 attacking vectors presently. To me, IT-OT convergence is not just the OT network now being connected to IT network or the cloud. It's more about OT environments are now equipped with IT technologies like networking, operating systems, and etc. So hackers can use the same techniques they break in IT to break in OT systems. It's the same Active Directory servers, the same database, and same system vulnerabilities. Hackers figure out they don't always need to do the hard way. In Trend Micro's 2020 annual cybersecurity report, although government and banking are still top 1 and top 2 of the victims being attacked by ransomware, we have seen many verticals with OT or ICS have been listed in top 10, including manufacturing, healthcare, food and beverage, and oil and gas. Especially manufacturing is now a top 3 target of ransomware. And in the same report, you can see how popular the ransomware business is today. In 2020, Trend Micro had found 127 new ransomware families, and 8 out of top 10 most detected ransomware families can also be found in OT and ICS network. Again, hackers could use the same techniques they hit IT to hit OT. Now, let's take a look of the involvement of ransomware. The first generation ransomware was quite local because they didn't have a good way to monetize. Usually, the ransom payments were sent by sending the short message to a premium rate number or being requested to add money to a e-wallet. But now, no one is still using this model. And then cryptocurrency like Bitcoin was born and changed everything. The second generation ransomware was with worldwide capabilities. It provides moderate monetization from a large number of victims. This approach has been used by actors for many years and normally poses a low risk to victims. And it's still preferable to some underground hackers today. Ransomware groups who make use of Model 2 do not perform deep victim profiling, while the Model 3 is related to more targeted monetization of victim assets. The ransom amount of Model 3 is also getting much higher. Actually, in some of the cases, the hacker group would ask like 30% of the victim's last quarter revenue. And I'm here talking about tens of $millions. Also, in the latest model, you can see hacker groups collaborate seamlessly. Some groups focus on getting the access and credentials, while some groups focus on deploying the ransomware. And some others may focus on infrastructure and logistics. Sometimes I may wonder, maybe the collaboration between hacker groups are actually better than us, the security companies. Just kidding. And as I mentioned, hacker groups can focus on deploying the ransomware payload without worrying about getting the access and credentials of the targeted victims by paying to other hacker groups. And once they get into the victim's network, they will drop the backdoors and the ransomware payloads. Here, you can see different ransomware families could use same malware loaders. The common mistake is to assume that an IR ticket can be closed after removing the early stage malware files in the system. The dropping of additional payload and subsequent lateral movement could be missed in this case. We recommend that for any malware detection in an incident, you should carefully check if the malware variant is commonly used as an early part of a larger kill chain. If so, you should assume that the later stage of the kill chain may have already been deployed and they should be investigated and neutralized. Combining the IT-OT convergence and the involvement of ransomware technology, the cybersecurity impact to OT has been worsened. In a recent survey conducted by Trend Micro, where we invited 500 respondents, including 200 from US, 150 from Germany, and 150 from Japan. 61% of the respondents said they had suffered one or more cybersecurity incidents in the last 12 months. And actually 75% of them had a production outage. And 43% had the operation suspended for more than 4 days. And more than half of the respondents indicated the greatest challenge in OT cybersecurity is the lack of ICS cybersecurity solutions designed specifically for their system and devices, which we will discuss later. And now OT ICS attack vectors. So let's take a look of the current APT type attack vectors. They can be conducted by different type of actors, cybercriminal and cyber espionage. The former actors are driven by economics, which means the commercial return, while the later actors, the cyber espionage, are driven by state or country interests. For cybercriminal, from like the end of 2018, we have witnessed more and more ransomware attacks conducted by them. And initially, like several years ago, their leverage was to encrypt the important data, and they would not give us the to restore the data unless we pay. But the actual impact to manufacturers and critical infrastructure operators is the corresponding production outage. The mission critical servers have been encrypted and couldn't do regular jobs anymore, and therefore they have to stop the operation. The economical impact is so compounding. And furthermore, now hackers will actually do 3 steps. They steal the data, kill the OT process, and encrypt the devices. They steal the data because they can extortion on it by disclosing the sensitive data or setting them on the darknet. They kill the OT process to make sure you will have a production outage, and so make their ransom look more convincing. It's really bad. And for cyber espionage, normally what they want is either breaking something or creating the panic. So sure, production outage is a must, but it's better with environmental disasters or even human harm. In order to do that, they need control over the actual field devices. Like in Stuxnet, it was the centrifuge, where it was the circuit breaker in Black Energy, or the safety system controllers in Triton. So here, I divide OT into following tiers. It's similar to Purdue model, but my intention is to categorize them from cyber attack point of view. You have mission critical servers with important applications running on it. And you have control systems which interact with both those OT application and the underlying field devices. And you also have 2 kinds of devices at least. The intelligent devices who have its own computing capability or have integrated with HMI. And the passive devices which simply receive instructions from control systems and do the job. For OT applications, controllers, and intelligent devices, the 3 blocks in red, once these devices or controllers are destroyed by those underground actors, you will suffer from at least the production outage. For a cyber criminal with ransomware capability, once they get into the OT environment, they will manage to get the high privilege credential and deploy the ransomware on as many systems as possible. But for control system and field devices, normally they are not very organized like IT servers. So in this case, underground actors could exploit the system vulnerabilities to distribute the ransomware. Why system vulnerability? Because many OT devices are equipped with legacy operating systems and applications. And keep this system up to date and patching them is extremely difficult in most cases. And in cyber espionage's case, state-sponsored hackers usually leverage system vulnerabilities too. But the difference is, once they get the control, they will manipulate and misuse the controller and field devices to make the damage. Again, we have 3 red blocks here, but actually underground actors don't need to take them all. Normally, if they could control the OT server and critical OT applications, it's already sufficient for a production outage. Actually, the very recent cyber breaches at the Colonial Pipeline is the case. The dark side ransomware didn't break into the control systems, but the pipeline operation was suspended. If the actors could manage to attack the controllers and field device, by the way, the impact would be even bigger. like the damage to human and environment. Also, it will take much more time to recover. But protecting OT and ICS could be a little bit different from IT and cloud. Here you can see the Mitel, very famous Mitel attack matrix for ICS. Comparing to the IT version, we can see at least 3 major differences. The first one, there's no credential access tactics because the OT ICS environment may not be so organized again, and there could be no single high privilege credential, which can be used to administrate all the machines. And the ICS machines joining single AD server, this is not a popular case as well. So instead, exploiting the service vulnerabilities, which means just attack the system or service vulnerabilities, will be a better approach for hackers, as most of the devices are not patched like IT. And in Mitel metrics for ICS, there are 2 new tactics, and they are inhibit response function and impair process control, which relate to the interaction and control over the controllers and field devices. Last but not least, the impact could be more severe, like a loss of productivity and revenue and loss of safety. Based on the learning, we like to suggest some goals to achieve for OT cyber resilience. First and foremost, you really want to protect the critical OT server and OT applications. They may reside in OT server farm or even in IT server farm, but you have to identify them, your crown jewels, and protect them. And surely you want to have a layer of protection between the server and the ICS zones in order to keep hackers out of the ICS, or at least slow them down. And in the ICS zone, you need to protect the control systems and intelligent devices by having network segmentation between production lines to inspect the east-west traffic. It will be also very helpful because you can shield the system vulnerabilities and slow down the lateral movement. Last but not least, hardening the critical devices themselves will be the last defense and could be also very effective. Now, let's talk about some best practices. Again, first and foremost, we suggest to implement the network segmentation to prevent from worm propagation, contain the malware infection, and create barriers between IT and OT, and even between the production lines. Furthermore, implementing virtual patch is always a great idea, as asset owners normally couldn't patch the OT systems like IT. And therefore, having the IPS product, network security product, deployed on network could not only shield the vulnerable systems, but also mitigate the lateral movement to slow down the hackers. Thirdly, build the trust list for both endpoint and network. On endpoint, it could be application whitelisting, and so unwanted malware can be easily prevented. On network, based on zero trust principle, you should grant very least privilege to prevent the misuse of controllers or even prevent from the misoperation. For example, you only allow specific device to have full access to the critical controllers, while the other devices could only read the parameters or read the logs. Then cyber breaches like Stuxnet or Black Energy could be mitigated. Last, you want to harden the critical asset and protect the endpoint systems by detecting and blocking the ransomware once it's been deployed. Now let's get to how to implement these practices and what are the real obstacles. So number one, network segmentation. Network segmentation provides the capability to segment the ICS network topology into different zones. And therefore, we can not only secure the north-south traffic, but also shield the east-west traffic. And unlike IT, in the shop floor or plants, we always have many visitors, like system integrators or contractors. If we can have the network protection on every single production line, then even there is an incident in one of the production line, the malware will be contained without propagating to other places. And so the operation will not be interrupted by the embedded worm. Network segmentation will also slow down the lateral movement and make hackers' life much difficult and increase our opportunity to catch them before the real breach happens. It's actually like the watertight compartments or so-called waterproof compartments of a ship or a submarine. With the compartments, if the submarine got hit and there is a leakage, the water will be contained without flooding everywhere. But if without the compartments, it will sink very quickly. Some managers used to do network segmentation with VLAN, by the way. But that's far from enough because VLAN is a layer 2 access control. But nowadays, you will need a layer 7 protection to really look into the protocol and take it payloads. So here we go. This is what we call layer 7 network segmentation if you can do virtual patching together with the network segmentation. It's very helpful because it will shield the legacy and the vulnerable systems. As we talk about, you can never keep all the machines up to date, right? And therefore, it makes more sense to protecting them from the network. However, you could have tens of thousands of these devices in the shop floor, and that's why virtual patching has to go together with the network segmentation. Excuse me, like this. Once there is a zero-day vulnerability being published, and you will be potentially affected. With network segmentation and the virtual patching, the zero-day vulnerability could be mitigated, and you don't have to patch the endpoints urgently. Imagine the virtual patching is like the mask, where system upgrade is like the vaccine. You should wear the mask before the vaccine is available and before you got the shot. The third one, build the trust list on both network and endpoint systems. As we mentioned, especially in cyber espionage, nation-sponsored hackers would manipulate the controller like a PLC to make damage to safety and availability. But people don't really implement restricted access control to these controllers. So once hackers get into the ICS zones, it could be very convenient for these underground actors to achieve their goals. If we can build a trust list on the network, and not only on the IP address level, but more on protocol and control command level, then for those critical controllers, we can make sure only specific device has higher privilege to configure it. And for other lower privilege devices, we just grant them the privilege of read. They cannot stop, configure, shut down, or make other impactful changes. And so for endpoint systems, we should also have a trust list, especially those fixed function devices. We can learn about these legitimate executables and build a trust list accordingly, so that even hackers find a way to put the malwares onto our mission critical devices, the malware will not be able to damage anything because it's not on our trust list and therefore it's not allowed to execute. Having the trust list on both network and endpoint system will contribute a lot to operational resilience. And you know what? We can do the three practices together by deploying network security solutions in ICS network for both segmentation, virtual patching, and network trust list at a time. But unfortunately, conventional IT-based UTM and entry firewall may not fit well. For example, on the left-hand side, please see the diagram. You can either deploy the network protection to the by the aggregation switches and protect the underlying production lines. We call this centralized way. And with this way, a security administrator can deploy the solution in the server racks without going to touch anything on the shop floor. Or you can do it the distributed way by placing the network protection into every cabinet on the shop floor to protect the mission critical controllers or assets. But if you want to do the centralized way, you want to have a minimum 24 segment or 48 segment solutions, which fit the number of interfaces of your aggregation switches. And if you want to do the distributed way, a single segment ruggedized product in very tiny size and support both AC or DC power would be more ideal. But looking into the current off-the-shelf UTM and entry firewall, they are developed to protect the WAN, to protect the enterprise perimeter or branch offices. And so they have maybe 8 interfaces, 10 interfaces, or 20 interfaces. So it's in between. It's not enough for the centralized deployment here, and it's too much and overkill for the distributed model as well. Not to mention, the IT-based UTM may not understand the ICS protocols very well, and the whole design may not fit into the OT operations as well. For example, how easy you can swap a broken firewall without too much configuration. And if the device fell by itself, will it impact the fragile ICS network, and etc. Here, I'd like to give you a quick example of TXOne's product. They are natively developed for OT network security. The form factors of the Edge IPS series are very specialized to fit into the fragmented OT world. And the whole design of the user interface and the operation is also OT-centric. The next practice is to harden and protect the critical asset on the endpoint side. Because in many OT environments, the endpoints are not well protected at all. One of the reasons is that you didn't have to, right? Long time ago, ICS were air-gapped, and so people believe they don't need extra protection. But modern factories and the plants are interconnected, so the whole landscape has changed. But let's talk about some common challenges we have seen everywhere. Number one, OT devices are diversified. Some systems are so old that modern antivirus software don't really support. Some are fixed function devices and could be locked down by application whitelisting technology, while others are too dynamic to build the whitelist. So single product or technology will be very difficult to tackle the complex cases. And number two, people worry about the compatibility and performance impact to the critical assets. For example, will it avoid the warranty from equipment vendor if we install a third-party security software? And how if the software hurt the system performance and introduce too much latency? So people don't really implement adequate protection on these critical assets. But out of top 3 attacking vectors nowadays, and they are worm propagation, ransomware and the misuse of PLC. The former two attacking vectors, especially ransomware, are about damaging the PC-based endpoints like a server, workstation, and HMI. So it's really challenging. And according to Trend Micro's investigation, the majority of operating systems in OT are outdated. Literally, 2/3 of these operating systems are suffering from end of support from Microsoft. And in this figure, we see around 10% of our Windows XP and Windows 2000. But because Trend Micro collects data from, so in reality, there are more legacy operating systems sitting in the plant. What concerns us is that major security vendors have announced their product will not support these Windows XP and 2000 devices. And these devices, by the way, are not going to disappear anytime soon, right? So how to protect them has been an important initiative for many large enterprises we have engaged. And in a aforementioned survey, only around 50% of asset owners deploy antivirus product for ICS endpoints. The number 50% sounds like deploying antivirus on ICS endpoint has been a common practice. But in fact, this is not a binary question. You should have more deeper questions. It should lead to how much percentage of your critical assets have been installed with antivirus? Or do you turn on every possible detection? Or even how frequent will you update the virus pattern? These questions are important because from time to time, we witness customers, they install antivirus software on ICS endpoint, but they disable important detection technologies to avoid false positive and to avoid performance impact. And the update frequency could be like 1 time, 2 times per year. And all of this could reduce the effectiveness dramatically. But again, does IT-based antivirus solution fit OT well? The answer is still no. The environment are different. In IT, no matter it's office, data center, or cloud, normally we don't have to worry about the computing power. The network is not very fragile, and the latency is not so critical. And the system patches or the upgrade of operating systems are not just like a mission impossible. More importantly, every computer and server should be equipped already with cybersecurity software like antivirus or EDR, and the virus pattern for security products are usually up to date. But OT could be a different world, right? The old legacy systems are all around, and you couldn't upgrade the operating system because you worry about the compatibility and system performance. Not many devices are equipped with security protection, and even they do, some detections could be turned off for better performance and lower false positive rate. And the frequency of upgrade of virus pattern is like 1 time, 2 times a year, while the internet access is not available. And any pattern update could even lead to further validation by the regulation. So in short, OT is a much limited environment compared to IT. And in addition to the difference in environment, the antivirus product for IT has also much limitation in supporting OT. Many antivirus software, they are pretty heavy. They are so heavy because it got the legacy. The AV software supposed to catch the malwares from 20-some years ago all the way to today. In order to do that, the AV software would need several different engines to detect different kinds of malwares. And therefore, it could impact the system performance if the processor is not very powerful. Furthermore, the internet access or proxy is a must Given modern antivirus software, they need multiple updates per day to detect the known threats. And they need to send the file samples back to cloud for further analysis for the unknown attacks. So we believe existing traditional antivirus software would not fit OT environment quite well. So here, I'd like to introduce you TXOne's all-terrain ICS endpoint protection, the Stellar series. Instead of having only one product to cover the very different systems in fragmented OT world, we have Stellar Protect. It's a next generation AI-based antivirus product, which can secure more dynamic servers or workstations with modern operating systems like Windows 7, 8, or 10. And we have Stellar Enforce. It's a whitelisting solution. It can be used to lock down the fixed function devices with more legacy operating systems like Windows XP and Windows 2000. Both products, they do not impact system performance. And both products, they do not need frequent pattern update to maintain the efficacy. We suggest to separate the OT endpoints into two groups, using Stellar Enforce whitelisting to secure the fixed function and legacy operating system devices, while use the Stellar Protect to protect those dynamic servers and workstations. Last but not least, in order to manage thousands, if not tens of thousands of mixed products, we have Perifone named Stellar One to make the management efforts easy and to provide the central visibility and control. So let's talk about some real cases. Hopefully, that can give you some references in protecting your own OT and ICS. The first example here is a semiconductor foundry. Semiconductor foundry is normally a very highly automated, very complex one. It's basically a mixture of factory automation and process automation, because the manufacturing process involves a lot of chemical operations. Here, we implemented layer 7 network segmentation on edge switches. That include access control, virtual patching, and worm detection and prevention. And for those fixed function devices like human machine interface, HMI, and legacy operating systems, we install Stellar Enforce to lock down and preserve the operation. And on those very expensive tool machine equipped with PC boards, and on those dynamic server and workstations, we install Stellar Protect to detect malware and ransomware. All these products will not impact the precious system performance, and they don't need a frequent pattern update to maintain the high efficacy in malware detection. And we usually have very high installation rate in this site. The next example is a water dam. It happened before that the gate of the water dam been opened and resulted a water flood tragedy, which resulted in the loss of human lives. Now, they have installed Stellar Enforce to lock down the SCADA system and use the network trust list feature on our edge IPS to prevent from the misoperation or misuse of the controller. As you know, modern water dams are more automated, and the gate of the water dam could be opened remotely. So the operator really want to have the visibility on when and how the gate has been opened, and want to make sure the gate will be opened only by the privileged device. The third example is a medical center. The cybersecurity issues of hospitals are very similar to factories. Their networks are usually very flat, and the devices are very difficult to patch. And the medical devices are also equipped with the legacy operating systems like Windows 7 or even older. So having the network segmentation and the virtual patching deployed on the network can be very effectively helpful. Hardening those intelligent devices like MRI scanner with the endpoint lockdown solution will be also a great move by the nature of whitelisting technology. And the important point is the maintenance cost is also very marginal here. Then I'd like to talk a bit about the trend of OT cybersecurity. Here, I'd like to reference the famous 5 functions defined by NIST Cybersecurity Framework, the CSF. And they are identify, protect, detect, response, and recover. In IT world, we have the IPS technology from around 2003. And in 2011, we have more detection technology like the sandboxing, EDR, and XDR. So at this moment, we have gone through all this cyber defense lifecycle. But in OT world, it just started. In 2015, there were some startups coming up and they focus on identifying OT assets, identifying OT network topology, and the corresponding vulnerabilities. Although people are deploying firewall in their perimeter of OT, really deep down to the shop floor, the protection lines and the so-called level 1 and level 2 controllers, they basically have nothing to really protect these mission critical assets. And that's why we are suggesting to deploy both endpoint and network protection solutions against the cyber threats and achieve the availability of production. And at TXOne, by having more and more visibility and telemetry in OT, we will be able to conduct the OT asset behavior analysis and eventually lead to real OT XDR. That will be our future works. In summary, the cyber threats for OT and ICS are so real. Those underground actors actively target large enterprises and critical infrastructure operators, and they try to get profit off them. And securing OT and ICS could be a little different compared to securing IT and cloud. We also mentioned about 3 tiers to be protected, and they are critical OT applications, control systems, and intelligent field devices. If you fail to protect them, it could lead to at least production outage and even the damage to environments or human lives. You will need OT native solution to fit into the operations because modern IT-based products don't really take care of the issues like a legacy operating system, limited computing power, limited internet access, or sensitive latency. And we suggested some best practices from real cases, like network segmentation and virtual patching, and including building the trust list of network and endpoint. We also suggest to separate the OT endpoints into 2 groups. Use whitelisting product to secure the fixed function and legacy operating system devices, while use the ICS specific antivirus product to protect those dynamic servers and workstations. By implementing these practical and effective approaches, you will find yourself towards to the operational resilience and have more capability to against ransomware. And that concludes my sharing today. Thank you.